In this example in 9.1, we're going to look at the intersection of ray AC and ray DC. And as you work through these problems, you'll probably want to recreate this drawing for each one. As you'll see, we're going to be drawing on top of it. If you go on to another problem, you could erase it, but you don't want to have too much going on in one place. So what I'm going to do is I'm going to, just with my pen, kind of highlight or draw or color over the drawing so that we can see what's actually a part of ray AC. And then we'll do the same thing with DC and find what they have in common, since this is the intersection. Okay, so right now ray AC, now that would have to begin with A, that would have to be the endpoint, and it's included on that ray. And then every point in the direction of C, and that's going to keep going on forever and ever in that direction. Okay, so this ray could have actually been also called ray AB or ray AD, as long as we begin with A and include some point to the right of that. Okay, let's do the same thing with ray DC. We're going to begin with endpoint D. It is included on the ray, so we'll make sure and color that in. For ray DC, we want to go in the direction of C. It doesn't stop at C, it's going to continue going on forever and ever. Okay, so when I look now at the intersection, let's look at what those two rays have in common. Beginning with A, both rays have point A included. So it would begin with point A, and then everything, every point until we get to point D, which also would be included. And what we have as a result is a line segment beginning at point A and ending at point D. So the intersection would be line segment AD. There would be no circles here. If an open circle is drawn, it means it's not included, but A is on both of those rays. And another way we could represent that would be line segment DA. The direction that we name a line segment doesn't matter, as long as we start with one endpoint and end with the other. For our second example, we're going to look at the union of a half open line segment GF and a half open line segment FB. G and F would be the end points of the half open line segment. However, F is not going to be included. We'll have an open circle. And we'll do the same. We'll draw as if it were a line segment FB. However, half open, we've got to have B not included on that set of points. So I'm going to do like I did in the first example, and I'm going to draw over the lines that were given here. So half open line segment GF includes G, all the points in between G and F, but we want to make sure that we have an open circle at F because F is not included. And then on my half open line segment FB, I'm going to start with another color. I would begin with F, which is included, and I'll go in the direction of B. However, B is not included, so we'll need an open circle there. I'm exaggerating it a little bit so we can see it better. Okay. So my answer here, now one endpoint is included and the other endpoint is not included, but we do have, we're looking for the union. So we'll look for every point that's included on either one or the other. So it'll be everything. We're putting them all together. We're uniting them. So the union of those two half-open line segments would begin at G. It would include G, however it would not include B. So we have as a result another half-open line segment GB. Example 3, we're going to intersect angle EFC with line BC. Angle EFC has a vertex at point F, and that angle is made up of rays FE and FC. So here we have drawn angle EFC. Remember, this will continue to go on forever and ever past E. Just gives us the direction and lets us know exactly what ray is included on that angle. So angle EFC. We want to intersect that with line BC. Now, intersection is what they have in common. So we can see that angle EFC intersects line BC at point B as well as at point C. So the way that we'll write that as our solution would be listing those 2 points. Point B and point C would be the intersection of angle EFC and line BC.